All right. Thank you for coming. I guess some of you maybe came from the previous sessions. Who was in the previous session? What's new in SQL 14? All right. So right on purpose, I put my session right after that. Said you guys must be already warmed up on the new features and the new excitement we have. So these guys told you before, Dandy and Pat, what's coming, what's the promised land. What I'm going to tell you today is what we have in reality going on. Right? Right. And sometimes it's not the same, unfortunately. Right. It's never better. It's sometimes a little worse. So my name is Nicholas Dritsas. I'm part of what we've been calling for many years fondly SQL Server Customer Advisory Team. You guys know that team? Yeah? I've been here for the past few years as well. So since everything changed, now we are the Windows Azure Customer Advisory Team. Boo. But that's what we are, right? No, it's no boo, actually. This is good stuff. So we merged in Redmond, SQL Server team, BizTalk team, a bunch of other teams merged together, and by now we are Windows Azure Customer Advisory Team. This session is mostly focused around the largest SQL projects, both on premises and on Azure, and the key word over here is projects. So my team, what we do is, if you don't know what we do, is we focus on customer-facing projects that we're getting directly from customers, from our account teams, from the fields. We pretty much engage with the most complicated, complex, bleeding-edge kind of projects, both on premises and on Azure. So we're kind of the SWAT team from the product team that we engage, hopefully, with some of you in some phases of your projects, and then we come to advise you and ensure your project becomes a success. And we have a couple of websites, a couple of blogs at the end you see here. One is the traditional SQLcat.com, which we still maintain and publish documents. And the other is, of course, the Windows Azure blog in MSDN, which is a terribly active blog. If you don't know that, please visit it. You'll see we keep blogging over there. So the objectives of today's session is to learn about these large projects. And on premises, we're dividing it in two major sections. One is around OLTP. The other will be around BI. We'll discuss some of the major projects we got engaged the past year or so. And then we're going to discuss on SQL Azure. One is on the size, and the other, most importantly, is the patterns we see that SQL Azure is called to address and how. We'll see from scale up, from scale out, and the unknown. How you deal with sites that you don't know how much success is going to have. Will it be 10 users? Will it be 10 million users? How do you prepare for such a variety of sizing? So this is the numbers we have so far collected from our projects. These are really projects where we go and we run DB space used, and we do select stars and all that. You know, we don't believe customers telling us we have the sizes. We go there, we audit it, we capture the stuff. Right? Most of the sizes, because they're so big sizes, it may imply they are not your regular everyday customer, so many of those we're not allowed to talk about. Otherwise, we'll be in Russia looking for visa or something. Right. At least I'm not in USA, I can say this stuff. All right, so the largest single database we've seen is 350 terabytes. Partition like crazy, file groups read only. We'll talk some of the strategies, how you manage such a database as a single entity. Largest table we've seen is 1.5 trillion rows. Bless their hearts. They dare even to ask me, can we do online indexing? Sure. So again, we have a few strategies for those guys. Again, partitioning is the big thing. All these big sizes is you have to break it in manageable pieces to manage that. Biggest total data, one application using scale out multiple databases. We have 88 petabytes of system across multiple servers. But to me, the fourth one is the most exciting, 130,000 transactions per second system using perfmon. So we use perfmon. We tracked it for a while. to see how the curve is going, if there is any curve, if this was an outliner. And actually, we'll talk later on for this company. It's a online betting company out of Europe that tracks that. Fastest I/O subsystem we've seen is 18 gigabytes per second. And of course, that implies some crazy SSDs and Fusion IOs and things like that. We'll talk a little more about the Fusion IO. It's a good friend of yours. I don't know if Fusion IO, are they in Hub today? Are they presenting? I don't think they're there. They were in Australia. They brought all the new Fusion IO devices there. It was pretty exciting to see that. We had to get a lot of aircons, though, because that thing gets very hot. Fastest real-time cube, millisecond latencies. We have some trading companies, financial companies, they want to track on a cube level. How many of you have used cubes before, analysis services? Wow, excellent, a lot of you. So you do understand the challenge here to have such a such a small latency to refresh your data in the cubes is extremely challenging. So we did a lot of tuning around with real-time roller partitions. And we fixed some items in the product as well, which by now you're using in SQL 2012, to ensure the queries are really passed through. There's no caching. It's a really direct interaction with the relational database. Another KPI we're keeping in mind is how fast a terabyte of data can load in the system. So the fastest we've done so far is 30 minutes to load that. The way we do that is we have published papers in SQLcat.com if you're interested to see that. We're taking advantage of the NUMA nodes per server. So in simple terms, in integration services, we're creating, let's say if I have 12 streams and I have 12 NUMA nodes, I create 12 tasks in integration services, and I map each task to a NUMA node. Not to some generic server, but you actually go to the NUMA node, you go to the port and the name of the NUMA node, and there you have full parallelism. There's no hitting each other. So in a way, if your server has more NUMA nodes, as you're getting more cores, you can add even more tasks and even increase this capacity even better. So if you're looking to have very fast data loads, go to SQLcat.com, search for those. We have a white paper to tell you how you do this stuff. Largest MOLAP cube we have to date is 24 terabytes. That's one cube. Is that big? Yes? Is it frightening? Like every morning, it's like, do I have to reprocess this thing? Oh my God. How many years is it going to take? We have a public case study for that. That's actually yahoo.com. So if you have 24 terabytes a cube, you can realize how big is the relational database. It's almost half a what is that? Petabyte. 500 terabytes, more or less, of data. So this is all clickstream analysis is done. We're testing, of course, as well HD Insight with these guys, our Hadoop implementation in Azure. We have about 80 nodes cluster spinning in Azure, processing this data as well. But I want you to see that as well. So this is the key numbers we see. If I do this presentation next year, you'll see hopefully different numbers, bigger numbers. Every year is getting more and more. SQL Azure. Okay, I don't have any marketing guys here, so I don't know. I'm from the product team. We started calling it SQL Azure. By now, it's called Windows Azure SQL Database. So don't get me in trouble if somebody asks you what was the session. Say Windows Azure SQL Database. But when you send emails to the product team, call it SQL Azure because I don't know what you're talking about. All right. SQL Azure has been around from the beginning. We introduced Azure as a service. It's a platform as a service offering. It's not the infrastructure as a service. Infrastructure as a service is where you get a traditional Hyper-V VM type and you install your SQL 2012, 14, what have you, and nothing changes. Here is more platform as a service where you don't care to provision servers. It's a shared pool. Kind of a consolidated pool in a way. You don't care for licensing, for administration, for patching, for sizing, for high availability, for disaster recovery. What do you care then about? Except of paying the thing, which is, by the way, $10 a month for a database. What do we care is how to size it, how to know that it's reaching some limitations, which I'll tell you that they exist, and how, in a way, to use it to really scale out. Because here in Azure, in the cloud, there's no scale up, on-premise as well. A scale up has a particular threshold, a limit. You always have to plan from the beginning. How do I go beyond that? How do I architect my solution to do that? So the largest sharded database, pretty much in the cloud, we see mostly sharded databases. SQL Azure, the maximum we can have is 150 gigabytes per database. So that's your limit where you're starting from. So if you have 20 terabytes of data, you're going to divide that by that, and you have hundreds of databases, which is not bad. I'll tell you why. The largest number of databases in a single app, okay, I did that last week, is 14,000. I checked this morning, is actually 23,000. So I need to talk to our data center guys soon, because we need to buy probably more servers there. Yes, we know the cloud is infinite capacity, but there is some. It's not like we keep putting servers over there. You saw the video of Scott yesterday, some heavy guys pushing this stuff. So we have openings, by the way, there. And Asia this year, at least the next couple of years, is, if you noticed, is the biggest investment Microsoft is doing on the cloud, Asia. 2 in Australia, 2 in Japan, 2 in China. We already have 1 in Singapore, 1 in Hong Kong. So we're going to have 8 data centers in Asia within a year or so. This is the biggest concentration of Azure data centers we have in the world. Then Europe will be the second one to come up. Most concurrent users one app had on Azure was 3 million users. And that, of course, we had to deal with sharding the database, because every database in Azure has limits, right? Because that's how it becomes a good customer, a good citizen in a shared pool. So every database can get up to 0.25 cores and about 30 to 40 IOPS. That's one of those small databases. Now you can have thousands of databases, and they're spreading out, and you have this accumulation of that. Not to worry, if you need more cores, if you need more IOPS, if you need more, because we are SQL guys, 0.25 core, what is that? Although in Azure, in a cloud world, that's a lot. So we introduced also something recently. We announced it in TechEd in the US. It's called SQL Server Azure Premium Edition. And it has a feature is called resource reservation. So you can reserve per database. We have 4 sizes: cores, IOPS, bandwidth, memory. This is pretty much like a resource governor kind of type. And we have P1 to P4. So you can go 1 core, 2 cores, 4 cores, 8 core, up to 8 cores per database. So if your application uses 20 databases, you can choose these 3 databases are very important. I'm going to give them 8 cores dedicated. The other one, I'll give them 2 cores. The other ones, that's okay. Their application, they can be in the shared pool, and then, kind of coordinate from there. We give you the ability to go from size to size very easily. It's a configuration setting. You can go from 1 core to 2 cores with a simple configuration change on your server, and there you are. You can provision much higher resources for your database. So this is some of the numbers we see for our SQL Azure databases. It's mostly scale-out systems, sharded databases. A little for the on-premises now. How do we see all these big terabytes? Let's switch our heads again on on-premises. How do we see all these large databases, large terabytes, trillions of rows, whatever managed? Nothing earth-shattering over here. People following compression heavily. But sometimes in these big databases, they're making a technique, because partitioning is there as well. The latest table, the current table or partition is not compressed. They're compressing everything else, but they leave the current one uncompressed, so the I/O, the import-export, is much faster, because compression gives you an overhead when you have massive inserts or updates in the system. Table partition, you hear that again and again. Partition views. File group and file management. This is paramount. You need to know extremely well, inside out, to the last iota, how you do file group and file management when you have a very large database. That's your lifesaver. And we'll discuss how, for example, Samsung is managing 80 terabyte of system out there. Caching is our big friend, and especially when we talk in Azure after this one. We released recently Azure caching. So it can go up to 150 gigabytes in a cluster. So caching is a very big thing to consider, how to take advantage of that to minimize the load on the database. And we'll talk for a couple of techniques from the architecture side, how you can create service-oriented database architecture, and the good old one, data-dependent routing, where you have a central database that receives the request, and then based on some parameters, metadata, it sends you to the actual end database. So we'll discuss these things as we move forward. So as far as the on-premises systems, I was supposed to start my timer. All right. So somebody remind me before lunch. We're supposed to finish what time? 12:55? Okay. We'll make it, don't worry. So for the data warehouse BI, I want to discuss with you some of our big customers. They focused on a kind of fast-track data warehouse system. They loaded 80 terabyte system. They wanted a very fast this subsystem, plus they wanted to set up a system to scale out analysis services and reporting services. So let's see on that. So Samsung, which is the large electronics company, wanted to build a system to monitor, to capture the information from the sensors. So this is the division of Samsung, it's the semiconductors, and they're making all these DRAM chips and all these memory chips. So there is a huge conveyor that goes across, and there are sensors there. So depending on the feedback, they can capture quickly if there are any quality controls and react. The point is to stop it or adjust it or what have you. So we're getting a lot of information coming through. They wanted to keep 36 months of data in the system from the sensor data to see patterns, trends, and all that. So that calculated to about 8 terabyte compressed information. That's a lot of data there to manage. So the strategy we took is we created a table per month instead of partition per month. The reason for that is because every table, then we put it in its own file group. No? So I have 36 file groups. So being on a file group level, I can do partition and backup on a file group level. Right? So the file group 0, which is the current one, it was not compressed. That's where all the data was coming in. This is nice because it's all inserts. I mean, there's no updates, there's no deletes, it's all inserting new data. And then the other 35 file groups, we mark them as read-only. We back it up once. And then every night, we only back up file group 0 because the other 35 are already read-only, already in the cage, backed up. So if we need to restore, we don't have to worry about. We did simulate DR scenarios where the database got destroyed, for example. So we do support, as you know, in SQL, partial restore. So we restore the primary file group, and then we restore the file group 0. So at least we can start collecting information. And then every night we would restore file group 1, 2, 3, 4, and they're kind of going backwards from there. So that worked quite well. So you may say, what kind of system supports that? It's a little small, the letters. It's a DL980 HP. And by now we're using all the cores we have over there. So we're using actually 80 cores. And we started with a half a terabyte of RAM. Now we are 2 terabytes of RAM over there. Yeah. Talking for buffering there. The only challenge they gave us, though, this is kind of obvious. Okay, I'll get the biggest, meanest server I can get, all the memory in the world, great. They wanted to build fast track on on a Vmax. So how many of you are kind of Sun guys, I/O guys, disk guys? You guys like to play with Sun, Vmax? Yeah? Okay, there are 2. The others, I don't know, give me an SSD, I'm happy with that. So do you know our fast track architecture in SQL? We have some prescribed architectures where you can use different pre-configured systems from HP, from Dell to get that. So they like the architecture style of fast track because it has a number of small arrays. Instead of a big array, gives you, 20, 50 arrays, RAIDs of 4 or 5 disks. It's a very well optimized. Vmax, if you ever use Vmax or any of these big kind of virtual LAN kind of devices, they are not optimized for that. I mean, they don't know this kind of concept. But these guys wanted to use that because it's an enterprise kind of edition disk system. So we calculated how many enclosures we need to reach the levels of IOPS they need. There are some formulas out there, how many disks you need to reach IOPS. We needed 5 enclosures of VMAX. So that's about $3 million. So, yeah. So HP was happy. They sent us flowers and all. I know HP is here. So, but that's what the formula is. You need these IOPS, you need to buy so many disks because they have redundant and mirrors and this and that. And pretty much they only say the best one we can do is RAID 5. So anyhow, after going all these conversations, we ended up with this kind of infrastructure. We chose 88 disks of 15K RPM each, 8 hot spares, 80 data disks because the 8 are hot. And then we divided those by 4. So we ended up with 20 RAID sets of 3+1 in the system. And that gave me a decent, not fantastic, but a decent 2.8 gigabyte per second scan rate in the systems. We have a white paper in SQLcat.com. If you face a similar infrastructure that they want a VMAX or some of these big enterprise like Symmetrics as well, or those. These are not necessarily made for data warehousing. They need some kind of tuning on how to put it together. Hilton Hotel. So I've been talking about them for a while, so maybe some of you heard it, but I think it's great for new people that haven't heard it to hear that because it was a great challenge. These guys have about 3,000 hotels across the world. And it's a centralized system where every hotel goes every morning and does adjustment of their budget and forecast. So if you know the hotel business, every morning the hotel manager does that, and they're preparing the pricing for the day. So if you want the best pricing for a hotel, call the hotel around 3 o'clock, 4 o'clock in the afternoon. That's where the managers are panicking. I have empty rooms, what I'm going to do. So either you call them or Expedia picks up all the inventory and you go to Expedia and you pay some fees as well to get it, right? So they needed all this stuff nice and centralized. We had some challenges to meet though because they needed the cubes to be refreshed every hour at the maximum with 0 downtime, 24 hours a day. So after we opened a couple bottles of scotch over there, so how do we do that? We came up with that. So in purpose, I haven't changed the slide. It says on the top August 2005. So it was the kind of the beta of SQL 2005 when we started setting this up. In simple terms, the biggest change for us is because that time analysis services started supporting multi-instancing on a single box. So what we did is if you follow the process, it'll be challenging to point, you guys cannot see. So let's start from the bottom left, how in a way the data flow starts. That's my FTP server, a bunch of data arrives over there. Then the next server is my SQL server. I do my integration services, data load, that's my data mart. Then next to it, the third server, that's the analysis server that is keep processing. So this guy every hour wakes up, processes the data, the cube files are ready, fresh. Then the challenge was how to send those data at the same time across the next tier where I have 6 analysis servers in a cluster supporting all my clients. Because you didn't want one OLAP server to have obsolete data, the other new data, because this is a web server. You may start in server A, you click next, you may go to server B. And then what do you do there? You see the old data. That's a mess. So what we did is a simple strategy. On a page, we agreed on the application level. At the page level, we're using the same connection string, not on the query level. So as the page refreshes, I may have 10, 20 queries there. That uses the same connection string on the top of the page. And what we do is we have 2 instances of analysis server in each of those servers. So one is the queryable, the other is to be updated. So when the processing server finishes, we use good old robocopy. Guys use robocopy? Good. Good old robocopy because nice multi-threaded. So in analysis, in integration services, simply we had 6 tasks in parallel using robocopy, synchronizing Delta, the data directories of to be updated session. And when we got success from all 6 of them, if one failed, we wouldn't proceed. If all of them got success, then we would change the connection string on the pages. And then we expect in about 5-10 minutes everything to drain and kind of swap over. Now, there were a couple of challenges over there. How about if there were long-running queries and they're waiting over there? There are some queries, they stay there for days. And, there are some tasks in analysis services that won't commit if there is a running query. It used to be like when you build a database, when you restore a database, those things would block. We'd get blocked from a running query, and then they would block everybody else. They would stop everybody from coming, but they wouldn't commit even. So we fixed a bunch of stuff in SQL 2012 to ensure there is a command, if you ever do that, it's called force commit timeout, which means it's gonna, if it waits for too long, all these restores and all that, it's gonna clean up everything in front of it, it's gonna kill it to make sure it progresses. So if you do this kind of setup when you do your restore commands, ensure you put the property force commit timeout, let's say 20 minutes, 10 minutes, whatever you like, and ensure everything cleans up and moves forward. So that's where we have today. Another lesson for us was the reporting services. We found out we cannot scale more than 40 to 50 concurrent users per server. Whatever we did, and we did a lot of things, we could not go more than that. It's kind of a magic number. We thought some hard-coded number somewhere. So anyhow, use it as a reference. This is when you have reporting services accessing analysis server. SQL Server is much higher, the scalability, but with analysis server, maybe because they add the OMD and all that, there are some limits that is about 40 to 50 concurrent per server. That's why we have 4 servers on the top right to help us here. All right. So as far some patterns on the OLTP we see scale out, scale up. Well, don't get too excited with the scale out story, by the way. The third one was no downtime allowed, ever. Talking about this ever, anecdotal. The Olympics coming in Russia, the Winter Olympics next year. So I was there 2 weeks ago in Moscow in a meeting. We're planning, the whole site is going to run on Azure and SQL and all this good stuff. So in the middle of the meeting, the Russian Prime Minister arrives, Sputnik. So he says like that. These will never go down. Goodbye. We didn't ask what that means. And can we give you 4 nines SLAs? You don't ask these things. Don't bring it down. Okay. So don't hit the website too hard, okay? Wait. All right. So that's another pressure point we have over there, too. That's where we're counting on caching a lot. We're going to cache a lot, this stuff. We know now. So one of the systems for OLTPs, and it's a very important system for us, is we call it the commerce system. All of our billing system, all the Microsoft billing by now goes through a single centralized system. Azure, Live, Xbox, all of our main properties, wherever we can make money. Well, Zoom is kind of, okay, I should remove that. I don't think we make money on that. So we had to manage 13 payment methods, 42 currencies, 65 localized markets, and they gave us 5 DBAs. Right. So we had the whole argument. If that was Oracle, you had 50 database DBAs and all that. It says, you want Oracle? We'll give you Oracle. So we stayed with that. So this is the platform we have today in production. Some numbers I want to throw. We don't use VMs. We're using 220 actual servers, physical servers, 736 databases. In bold, we're growing 12 terabytes a month across all these databases. A lot of mirroring. We're doing a lot of mirroring, especially asynchronous mirroring. Yes, we have some of them auto failover and everything, but we do not really believe on that. When I'm saying we, this group is part of my group is part of the product team. That's why the SQL team actually built that commerce side for Microsoft. It's running out of Shanghai. We do use a lot of log shipping pairs. We believe log shipping is here to stay, and a big production system like that is very lightweight, very easy to set up, very easy to monitor. You notice we're using replication a lot, and we're gonna remove that. We're gonna go to always on asynchronous, and if you guys using replication, that may be something to consider too. Always on is definitely much more appropriate, and that's where we're investing a lot compared to replication. So you may say, how 5DBAs manage 200 servers out there? Except a lot of coffee, don't sleep, things like that, which they do. SCOM. So they took SCOM and they programmed the heck out of it. I mean, SCOM doesn't look like that, but you can make it like that. So centralized view of the data, a lot of alerting, a lot of alarming when things go in a haywire over there. So far, we didn't have any major problems. We are we're kind of conservative over here. We don't really deploy the best and latest or betas or whatever. We've gotten an exception from the headquarters of Microsoft not to deploy beta on that, although they want us to deploy beta. So anyhow, this is just an example of a system. If you want more information, you can send some information to sqlcat.com. Our team in our websites, we have also a communication. You can communicate with us. If you have an environment like that, we can share some more details. This is kind of a more traditional system. This is a large healthcare provider. They worked with us. Couple of interesting items with them is 10,000 concurrent users. I would say they took a different approach how to do high availability. They used the SAN level replication. So SAN level replication, if you know, takes the whole SAN and then replicates it across. It's much more expensive because you need a duplicate of the whole SAN, but it gives you much higher fidelity that the whole storage, the whole rack is on the other side as well. It does support SAN replication, both synchronous and asynchronous mode. And we found out things are moving. It used to be we say you cannot do synchronous if it's more than 50 kilometers away. It was kind of the speed of light and the speed of fiber and stuff like that. It was getting too slow. We recently did, and we're about to do a white paper. Of course, everybody's challenging that. Was it here? I don't know if it was New Zealand or Australia. Anyhow, we worked with Telstra a lot. We tuned up a lot of the system, and we stretched the synchronous to 120 kilometers with no impact. Synchronous. That's two-phase commit across 120 kilometers. So keep that in mind. Barriers are moving. So synchronous, that's always on synchronous. It's very compressed, very smart. The packets, the way they build are okay. The fiber is getting better, all this stuff. So you could have synchronous DR by now up to 100 plus kilometers. So keep that in mind. So the 120,000 transactions per second I was talking to you about is a company called BigWin. Have you heard of BigWin before? No? You guys not betting much, huh? All right. So these guys are based in Austria. I think by now they moved to Gibraltar or something like that. I had to check it in Wikipedia. Where is that? So then when I saw it, I said, that's why. No taxes there. So there is a theme apparently over here. They're using 5DBAs as well. So you have a complex system, you get 5DBAs by now. Some prescriptive thing over there. Maybe they followed what we did, I don't know. 200 databases, 150 terabytes of data, 4,000 databases, 2 petabytes of storage, blah, blah, blah. This is cumulative stuff. They doing so many transactions. I mean, the numbers, frankly, guys, are irrelevant. I mean, depending on the event, depending on how busy the event gets, they're getting hundreds and hundreds of transactions per second in their system. So no downtime allowed. That goes without saying. Even a second down for them can be, I don't know, one bet can be $10 million, $50 million kind of bets. So not only they wanted high availability, but they wanted that performance to allow them to do more dynamic kind of a pop-up betting. It used to be in a soccer game, okay, before the game starts, you bet who's going to win. Then the betting closes, you wait till the end. You either win or you lose, or there's a tie or a typhoon or whatever, and then that's it. But now they opened it during the game. They're doing they call it pop-up betting. So let's say there is a corner kick. So the opening for 1 minute quick betting. To bet is going to go head or left or right or pass or where it's going to go. Or penalty kick is going to be caught or not, things like that. So imagine how dynamic you have to be. You have to create structures in memory, very fast structures. You have to deploy it. You may be very successful. Everybody wants to click quickly. The more they click, the more they process the system. So the hackathon stuff that Dandy showed you before, the in-memory database, they're there. I mean, most of their sites now, they're running all using SQL 14 in-memory database technologies to support this kind of volumes. For high availability, nothing special, nothing exciting. Everybody can do that. They're using synchronous on premises. They're using synchronous across site about 80 kilometers away, and that's the automatic failover for them. And then they have an asynchronous as well for reporting purposes. So all the reporting, it doesn't hit the main system, it goes to the other system at the bottom. They're using a Fujitsu server, 64 core, 1 terabytes of RAM, multiple 1 gigabit NIC interfaces. I don't know how many we have, like as many PCI slots we have, we put 1 gigabit cards over there, because that's one bottleneck, is how fast they can move data across the network. That's a big bottleneck for them. The other big bottleneck, of course, was as obviously I/O, right? And what is the only I/O in SQL you cannot avoid, no matter what you do? Everybody? Excellent. That reminds me. That's worth a bug. I was given 3 bugs to give you guys, so I need to ask you questions. So this has a lovely, apparently iPad envelope. I'll give you the bag, don't worry. It has a little thing, a little Microsoft thing. I'm like a salesperson. And it has a Cloud OS t-shirt. So you go down to the registration and you pick it up. Right? Stay alert, there are 2 more.
Thank you.
I was told one of them has a luxurious bathrobe that has a t-shirt. Maybe from the hotel. All right. So transaction log. Whatever we did, we put memory, we put so many cores, transaction log. We could not get we don't have 0 transaction log in SQL. There is always something there, no? So they went first and they put an array of 400 disks. That's for the transaction log. Like, right. Why 400? They're like, what, 800? So no, that's fine, that's enough. I mean, you cannot, there are things, they are latching, there's blah, 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 there's all these things. So when you go to traditional disks, there are things that the disk has to wake up, they have to do stuff, there are motion things to happen. Then Fusion I/O came, all right? So by now, they're pretty much, they got rid of the disks, they're extreme guys, they're using only Fusion I/O. So you see this big server over there, big server, and they put all, I don't know, like 12 PCI cards of Fusion I/O, 2 terabytes each in space, right? Then what was the problem, you think? The problems never end. So after we put all these 12 Fusion I/O, the next problem was? What's that? No? Heat. So I'll give you the next bag. This thing got so hot over there. So apparently the DL980 has an alert that if it goes after a certain temperature, it shuts down. Says, I'm too hot, bye-bye. So we had to call HP and this and that. Bottom line, we had to put 3 air cons right on top of the server to suck this thing out. There we are. Now we're talking how do we do DR of the air conditioning and all that. Anyhow, all these bottlenecks are gone from these guys. They're very happy. They're very excited. So they have in memory the database. They have Fusion I/O for the logs and all this stuff. Because even in memory, if Dandy told you before, we do use some logging to track what's going on in memory. It's not like if you turn off your computer, everything will go away. Unless you have in memory, as he told you, probably non-persistent tables. This is very exciting because all your temp objects, like tempdb, temp tables, instead of going to the tempdb database, they can go in memory. But still use it as a table, do joins, do all this stuff, but you don't get the overhead of the tempdb connectivity. All right. So I wrote a couple of articles from those guys at the bottom. I don't have to go through the other one in SQLcat.com. One of them, they did 2 terabytes per hour backup over the network. So there are some techniques how to set it up, how you tweak it. Yes, you need to have a boatload of network cards to do that. It's all on the pipe, how quickly this can move. And the last one is how they achieved 99%, what do they say, for the reporting, how they boosted the reporting. A lot of that is by keeping an asynchronous copy of the database using always on another data center, so there's no conflict. There they used also column store. They added column store, if you heard of that. And especially now they're very excited because column store is also updatable. They don't have to do all this partitioning, switching, and everything. So that helps them a lot. This is another customer, of course, and maybe you one day, you'll be up here, where we making features because some key customers need us. So one of their needs were to have a updatable column store. The other I didn't mention is they wanted 15,000 partitions per table. Right. We used to have 1,000. Now it's 15,000. I'm sure somebody will come from you and say, I need more. So we'll make more. So how did the project scale up? In pretty much what kind of items they used? They used table partitioning, as I said, a lot, NUMA, and scale out, kind of the same story. So we don't have really scale out from the database level, but you can do it with a database sharding methodology. Just to show you a little some of the options we have for the scaling up. So today, as you know, we support in 2012 up to 640 cores and up to 4 terabytes of RAM, both Windows and SQL Server. Now, we don't have a 640 core physical box yet, right? But we have 256. So here's how it looks like. So we have some problems here. We have to fix that task manager a little. And having a box with 2 terabytes of RAM and 256 cores to reach 90% or 80% capacity of the CPUs, it took us a long time. Because we found out each of these cores has like 16 megs of L1, L2, L3, or 4 cache. They have humongous amounts of caches. So it took us a while, but there it is. I mean, if you look a little closer, you see every CPU is going pretty high over there. That's a Silicon Graphics server. If you're interested, what is that? So you're not going to run, I expect, something like that. If you have a big box like that, you're going to Hyper-V the heck out of that. You know, you can make another 10, 12, 20 servers out of this. But if you need, Big Win, though, is going to go there. Big Win is going to ditch the 64 core. They're going to go over here, single box, 256 cores. But if you guys ever go like that, please adjust the degree of parallelism on your queries. Yeah. You know, don't leave it 256. You know, this is not gonna. It's not gonna help you. Actually, it's gonna hurt you. You know that a lot. We very seldom see anything more than 8 or 16 helps. So that is going to increase a lot of your parallelism as well overall. You know, keep your server level max DOP about 8 or 16. You know, do some testing over there and see if that works well. Yeah. Scaling out, how do you manage that? As we said, breaking it down in manageable size pieces that you can manage a little better. So table partition is a very, very important thing. As you learn the file management, please learn very well how you do table partition as well. How you manage the partition, you're creating it, how you do a proper partition in the system. Now, you could do multiple tables, and the tables have their own partitions, and then you can join them under a view with supporting views. Through the view, you can do select directly by using the view level versus the table levels. Those tables can also spread across databases. So we support a view that has tables across databases on the same server, can be also across instances. If it goes really complex and you really want to scale out, you may have heard, I'm not going to talk much of that, that's our parallel data warehouse appliance. That has the whole concept of a control node where it takes your query, both insert, update, and select, and spreads it out across X nodes and, you know, creates all the scale out story for you, right? This is a very exciting technology. I think we have some sessions on that, but this is for the multi-terabytes of systems, especially decision support systems that we can scale up to 400 terabytes of systems today available in the market. Dell has devices like that, HP has, and some other vendors are working on that. We're very excited about this one because if we ever make this one updatable as well, that'd be nice. For now, please consider that this is read-only primarily. Yes, you can put data in, but it's not OLTP device. It's a data warehouse device, right? SODA is the good old one, service-oriented database architecture. The idea over here is when you're architecting your system, you divide and you identify the main services of your application and you put them in their own databases. Login, security, billing, accounting, inventory, all this stuff. So you're spreading across multiple databases per function. And then you can do joins across them. DDR is a big thing, data-dependent routing. It's been around for a while. The idea is there is an entry point database that has enough metadata to send you at the bottom to the actual database server 1, 2, 3, or 4. Every database server can hold, for example, a range of IDs, a range of cities, a range of something. And then when you're coming in based on your value, you direct it to the right database server. Azure is doing that heavily as well, database routing to be able to scale out. So let's talk a little for the Azure guys. So Azure has been around. Has anybody worked, did anything on SQL Azure so far here? You guys want to get at Aston Martins, right? All right, so start creating some databases there. It's kind of funny, they didn't mention that in the Australia TechEd last week. Either we missed it or there's some tax issues over there. But it's been going on since May, so it finishes in September. So if you have especially MSDN subscription, go ahead and do that. It's nice. All right, so in Azure, you need to keep thinking on scale out. How do I utilize multiple databases, a lot of databases across, so it allows me, as I need more capacity, I simply add more databases and my application adapts. How do I use also caching? So we did release Azure caching, and it's considered as another web application in a way. The same way you deploy a web app and you can have a cluster, you can have like a web farm, 10, 20, 50 servers, and it's very easy to add or remove servers from a web farm. Caching is working by now the same way. It's kind of a web application because IIS, you can have caching on an IIS server. But now we make it easier for you. When you go to the Windows Azure portal, you can say as a first-class service, I want to create a cluster of 20 servers, and that's my caching. And each caching server is going to hold 6 gigabytes of cache. So 6 times 20, I have 120 gigabytes of cache. If I need more, I can add more. If I need less, I can scale it down. And then from your application, when you're caching information, you don't go to each of those 20 individual nodes. You go into the deployment name. All these 20 have a kind of a virtual cluster name. It's called, I don't know, my own cache. So when you go to my own cache, you can cache any kind of objects you like. You can add especially session objects, frequently select star kind of statements, anything that you see that is repeatedly asked by the system. We've seen systems improving by 50% going to cache. We see when we say 50%, the big enemy here you're fighting is not IOPS anymore in Azure, is number of cores. Because the number of cores is a very limited, very important resource for you. So your indexes must be very well tuned, your queries in and out very fast. And you don't want to have in Azure, by the way, a lot of conversations with SQL Azure. Instead of doing 10 selects, select, return, select, return, select, return. Do one batch, get all 10 in one batch, right? Because every time, I don't want to go to the gory details in Azure, but your web server has to go through the gateway and traverse and open connections, get the data. Then you close the connection. Then you open another one, you open, close, open, close. So generally, if you try to go to Azure, any of your applications, ensure they are not too chatty. You want them as less chatty as possible over here. And as I said, the last one is is the resource reservation we added recently that we allow you to have 1 to 8 cores per database. And the last one, which I didn't put over here because we just announced it, Scott, did Scott mention it? Anyhow, I'll mention it. We're going to do GODR as well for the databases in SQL Azure. So we'll allow you, like a very similar, like always on, It's going to be like a asynchronous always-on style. So you have one database in, let's say, in Australia, and then you can make a live copy of that in USA for DR purposes in case some of the data centers have problems. The nice thing is with those DR databases, they are readable as well. So you can have up to 3 destinations, one in Singapore, one in USA, wherever you want to send it out, and it's also readable. So that's pretty good. So let me talk a little of our patterns. Samsung Electronics. By the way, I work a lot with Samsung, if you noticed. So these guys, 2 years ago, they introduced a new technology. It was called Smart TV. Have you heard of Smart TV? Right. So after the engineers built Smart TV, they sent a marketing guy to register that as a pattern name. So this guy's been lost. They never patterned the name, and pretty much everybody's a Smart TV now. LG Smart TV, Hair Smart TV. So I think this guy is not in good terms. It's like Xerox, they didn't pattern the mouse, and there it is. So the problem was very great for the cloud, because they're going to have all these TVs. They were hoping to be very successful, but those smart TVs, they need a lot of touch. They need to update the firmware, they need new applications. I mean, it's like a computer, actually, that needs a lot of interaction, but it's a TV. They don't expect like the laptop to run Windows Update and reboots and this like that. This thing has to be self-driven. Now, that meant to them, they have to build data centers pretty much across the world to manage this kind of infrastructure. Right, that's expensive. So they did start doing that before we talked to them about Azure. They built the application in Oracle and .NET. And at the best, they were able to hit, I see it in the middle of summer over here, they hit 500 web requests per second they were able to do. That's very small. I mean, you cannot survive in a TV world like that. So by now, these guys, they're having 20 million TVs online, and we're counting. Yeah, we know exactly where they are. So we brought the system to Azure. We achieved 10x performance, and now we're achieving 5,000 concurrent web requests in the system. And it's not a huge system. We're using 10, it's a little further down, we're using 10 extra large websites. We chose to go from 20 large to 10 extra large because we discovered that the money is the same because we charge you per core. Right? Not per the size. So 20 large is 20 times 4, that's 80 cores. 10 is 10 times 8 is still 80 cores. So the billing is the same. But after doing some internal research and analysis, we saw the extra large has double the network bandwidth than the large. They're like, did we tell you that? No. So be careful when you choose the size of your VMs in Azure. Every size, the next size is double the bandwidth of the previous one. So small to medium, medium to large, large to extra large, everyone bumps twice the bandwidth. So that helped us a lot. We used IIS cache in those 10 extra large. Because we got to extra large, we got as a bonus much bigger memory. It's a fixed memory. We're getting double the memory from the large. So we allocated a bunch of that for cache. You don't have to use necessarily Azure cache and pay more. If your web server has enough memory, you can allocate it traditional IIS cache and store objects over there. Here's another one. Remember SQL in Azure, we don't have only SQL as the storage unit. We also have table storage. It's kind of our NoSQL implementation, key value pair kind of scenarios. So if you have in your application some functions, they are very heavily inserts, that is a place maybe to take it out of SQL and put it in a table storage. In my scenario in .tvs, every TV that we turn on, it would log. I'm in at 3 o'clock, I'm in at 5 o'clock. You know, we had some logging to see how, this is sequential, thousands and thousands of inserts, even millions of inserts. When we put it in a table storage, we saved about 1.5 core from SQL. That was a huge saving. So consider table storage as well if you're planning some applications there. What else? We kind of went pretty, this is kind of the traditional tuning. We went SQL, traditional SQL, a lot of stored procedures, a lot of ADO.NET. We didn't use Link, we didn't use iBatis. Is anybody of you using Link on .NET? 1, 2, 3. Okay, word of caution. Link is nothing wrong with Link, by the way. It's great. What we found out when we moved the Link-based applications to Azure on the web servers, Link is very single-threaded process and very heavy on CPU process, right? The problem is on our web servers, the CPU cycles are not as fast as your Intel boxes. So you may see performance issues with Link. So just prepare a little as you go in there. I just want to share with you what's going on over there. We plan to fix it. We plan to increase it. But in our data centers, we're running all of our servers running on AMD, not on Intel, because AMD is about 40% cooler than Intel. So if you run those big containers that you saw yesterday, 40% less heating is huge. Makes it the running of that much better. But it's slower. So Smart TV was an example of scale up, I would say. One database supporting 20 million potential users. Very simple in architecture. And all these big systems have to be very, very simple. Nothing too complex. This is inside on the top left. That is the on-premises. That's where the developers developing an application and they ship it up to the blob storage. Then from the blob storage, if you see the arrow, it goes to the Windows Azure CDN. That's our file caching in a way across the world, and then it's distributed. So when you download this file based on your location, it's going to point you, for example, to the Sydney server versus the Korea server, because you are closer to that. The Smart TV has kind of is keep checking for a particular web API, and then when we have a new update for them, they're going to grab it, install it, they're going to update the file, and then the whole cycle continues over there, right? So it's been going on for a couple of years now. We're very happy. We had some big spikes with the Euro 2012 and the Olympics, of course, in London. So the system is doing very well. By the way, these are the big events. Every time there is a Euro or Olympics, they sell a lot of TVs, these guys. Or where the Microsoft bonus comes. MYOB, you guys know those guys? Yeah? Excellent. So MYOB is an accounting system, small accounting system for small companies, thousands of customers they employ. Similar problem, but kind of a little different. Because all these small owners, they have a laptop, they're running MYOB, is using a little SQL server there, is doing something. Do they ever do a backup of this thing, you think? Do they ever do DBCC, check DB on this thing? Do they re-index, update statistics? None of these things happening, you know? Eventually they call tech support, my query sucks. All right, let's do something. So managing, I'm throwing a number, 200,000 customers like that, that's a hell of a work. So they were saying, how about if we centralize all these databases and have a centralized database management environment? And that's a benefit to our customers as well. They don't have to worry, is my database backed up, available, whatever. I take care of that, right? But at the end, they didn't take care of that. We decided to take care of that. So they came to Microsoft. They said, we're going to use PaaS, your SQL Azure, where you manage it, you maintain it, you do all this stuff. But the challenge is, I need 200,000 databases. Right. So we're opening our spreadsheets and everything. Do we have to? Because if you heard a little in SQL Azure, every database, when you create a database, we create 3 databases. Physical. That's our HA story. Every single database in the data center has a triplicate full sync copy running. So I don't need 200,000 database capacity, I need 600,000 database capacity. And then these guys, they decided to GODR in US as well. So another 600,000 databases over there. So these are good problems to have, but when you manage this kind of capacity, you kind of having different management options. You know, so we start thinking how to introduce a concept in Azure to manage a group of databases, not manage the database, but you know, have a little better metadata option. And you'll have that in your applications. You may have not 200,000 databases, but you may have 50, 100, 200 databases very easily. How do you set up some maintenance jobs for all these 200s? So that's where we're kind of working on that as well. So MYOB, some items I wanted to say. They're using Link. And we found out just the best practices. Small single core works much faster with link than extra large 8-core. Right? We can have conversations over beers, and I'll tell you why. But in simple terms, because it's single-threaded, that CPU never sleeps on a small, because it's only one. On the 8, CPUs may sleep. If this one goes to a sleeping CPU and it has to wake it up, it's going to take time. Right? So it's the sleeping part. So RVMs, they don't balance power. You can spend all your time trying to change it to full power. Don't worry about it. The base is always going to change it back to balance power. So some of the CPUs may sleep. So keep that in mind. If you have any single-threaded operations, small may be faster because the CPU never sleeps there. They're using kind of data routing processes. So there is a central database, and then that sends them to the far right to the actual physical database. And that's how they're moving on that. Let me go a little faster because I know we reached the time. Cache converters is, cache converters? Yeah? Pawn shop? Did I say it right? Pawn. I said it differently in Australia, and they were laughing at me. 1,000 store, 19 countries, different scenario. This is not an ISV. MYOB has 200,000 individual customers. That's one customer, 1,000 stores, point of sale system. Very important system. It cannot go down. What we did is we grouped per state. We did a multi-tenancy, we call it. One database holds about 50 stores. And then what we did is we did a GODR from Singapore to Hong Kong. So we're holding, let's say, per state, one database in Singapore, and then we're doing Hong Kong in case something fails. That's where they're going to go to. And there is some nice numbers to show you the data flow when you have time tonight. Pottermore.com. Has anybody visited that thing? So if you haven't, if you're a Harry Potter fan, maybe your kids are, or your mothers. When Harry Potter retired, everybody got a withdrawal symptom, so Pottermore.com was put over there for the Harry Potter guys to interact. This is the scenario where you don't know what your application, how big it can go. We started internally, and we hit the first one, as you see. We opened it, 4 million pages in 2 minutes. The site crashed. Beautifully. So I guess, okay, we need to do something more to scale. So we brought it to Azure, all this good stuff. By now, we're hitting, in the first 2 weeks, we hit 1 billion pages view, 15,000 registrations per day. We're hitting 84,000 concurrent peaks, crazy stuff. It was a silent launch in 2012. That's a new term, silent launch. Don't tell to anybody, put it out there, and they may find it, they may not, I don't know. They found it, though. And it works quite well. Simple system. One thing, and that's my last slide, I'll tell you guys, caching. The biggest thing for those users in Pottermore, in the social site, is your session object, your session. Because as you're going from page to page, you carry a lot of properties. I like blue, I like yellow, I like, all of your likes. Having 4 million session objects in any IIS memory, in any SQL server, that's madness. You cannot manage so many. We're going to be terribly slow. So we put a cluster of 200 web roles. That time we didn't have Azure caching yet. We used Memcached. You know Memcached? Memcached is the kind of an open source caching server. Now we have Azure Server Caching, which has the same APIs like that. So caching is a big thing. Please consider it to scale up. So that is my last slide, because otherwise you're going to kill me over here. There's a lot to hear. I'm going to be here this afternoon as well if you're interested. I have a conversation how you do always on in IIS VMs. So you can have high availability over there. Things are changing. Maybe next year I have more on SQL Azure, next on premises. I don't know. It's up to you. You give me more on one side, on the other side, we can have more. All right. Thank you very much. Enjoy your lunch. I'll see you later.